July 1st, 2025. A telescope in Chile detects something that shouldn't exist, racing toward us from the constellation Lynx at over 100,000 miles per hour, an object so massive it defies every model we have of what drifts between the stars. But here's what keeps astronomers awake at night. This thing, designated 3I/Atlas, doesn't just break the rules of interstellar debris. It breaks them in ways that feel almost intentional. Picture this. You're expecting to find pebbles scattered across a beach, and instead you discover a boulder sitting exactly where you're looking. That boulder weighs 33 billion tons, breathes gas like a comet, yet somehow ignores the fundamental physics of momentum that should be pushing it around. It's like watching a freight train powered by birthday candles refuse to budge when those candles are blowing full blast. Tonight, we're diving into the most unsettling question that 3I/Atlas has forced us to confront. Not whether this visitor poses a threat to Earth. The math on that is crystal clear. It doesn't. Not whether it's natural or artificial, though that debate rages on. No, the question that haunting researchers is far more profound. Did our radio signals somehow call this thing here? I know how that sounds, like science fiction wrapped in conspiracy theory, topped with a generous helping of human ego. But stick with me, because the deeper you dig into the timing, the trajectory, and the sheer statistical impossibility of what we're witnessing, the more uncomfortable the coincidences become. You a picture of, let me paint exactly how weird this situation has become. Since Marconi started broadcasting radio waves in the 1890s, humanity has been screaming into the cosmic void at light speed. Every television broadcast, every radio transmission, every cell phone call creates an expanding bubble of electromagnetic radiation, announcing our presence to anyone listening within a growing sphere, now roughly 240 light-years across. That might sound impressive until you realize our galaxy spans 100,000 light-years. Our radio signature represents a tiny whisper in a cosmic ocean. Yet somehow, just as our detection technology reaches the point where we can actually spot and track interstellar visitors, along comes the most massive one we've ever encountered, following a trajectory that seems almost surgically precise. 3I/Atlas approaches our solar system along an orbital path tilted just 4 degrees from the plane where all our planets orbit. The statistical probability of this happening by pure chance sits at roughly 1 in 500. Not impossible, but definitely eyebrow-raising. It's like throwing a dart at a wall from across the room and hitting dead center without aiming. But the timing gets even stranger. This object has potentially been wandering through space for billions of years, carrying chemical signatures from stellar environments that existed before our sun was born. Yet, it chooses to arrive now, during the brief cosmic instant when humanity possesses both the technology to detect it and the scientific infrastructure to study it in unprecedented detail. The Hubble Space Telescope swings into action within weeks of discovery. The James Webb Space Telescope captures detailed chemical spectra. Ground-based observatories worldwide coordinate tracking campaigns involving hundreds of facilities. We've assembled the most comprehensive surveillance network in human history, just in time to catch this particular visitor. Coincidence? Maybe. But when you start adding up all the statistical improbabilities, the mathematical comfort zone starts shrinking fast. Here's where it gets really uncomfortable. 3I/Atlas exhibits chemical signatures unlike anything we've seen before. The James Webb Telescope detected carbon dioxide emissions with a ratio to water vapor that ranks among the highest ever measured in any comet. This suggests formation in the outer reaches of some alien star system in regions so cold that carbon dioxide freezes solid alongside water ice. But here's the kicker. Despite showing clear signs of active gas production, this object barely responds to its own exhaust. When gas escapes from a typical comet, it creates tiny rocket forces that nudge the comet's orbit in measurable ways. It's basic physics, action and reaction. Yet 3I/Atlas shows virtually no measurable acceleration, despite producing substantial gas emissions. The only way to explain this disconnect is mass, enormous mass. Current estimates suggest this thing weighs at least 33 billion tons, making it potentially thousands of times more massive than previous interstellar visitors. It's like discovering that what you thought was a hummingbird is actually an elephant. This creates a population statistics nightmare that's keeping theorists up at night. We should have found dozens or hundreds of smaller interstellar objects before encountering such a massive specimen. Small debris gets ejected from planetary systems more easily than large objects. It's basic gravitational mechanics. Yet somehow we've stumbled across the cosmic equivalent of finding a blue whale before discovering goldfish. The detection sequence makes no statistical sense unless something is fundamentally wrong with our understanding of what's drifting through interstellar space, or unless this particular visitor isn't following the same rules as natural debris. Now, let's talk about the elephant in the room. The trajectory timing that has some researchers quietly questioning whether 3I/Atlas represents our first documented case of cosmic reconnaissance. This object will reach its closest approach to the Sun on October 29th, 2025, positioned directly behind our star from Earth's perspective. This creates a months-long observational blackout, just when the object becomes most active due to solar heating. From a surveillance standpoint, it's perfect timing to avoid detailed scrutiny during the most revealing phase of the visit. Some coverage has described this as intentional evasion, though mainstream astronomy maintains it's simply orbital mechanics playing out according to gravitational physics. But when you're dealing with an object that already violates multiple statistical expectations, even routine orbital geometry starts looking suspicious. The chemical evidence adds another layer to the mystery. Very large telescope observations revealed something genuinely puzzling in 3I/Atlas's glowing atmosphere. Multiple nickel emission lines blazing prominently in infrared light, while iron remained completely absent from the same spectra. This is like finding a forest full of oak trees but no maples in a region where both species normally coexist. Traditional comet chemistry offers few explanations for this selective metal emission pattern. Seeing abundant nickel without corresponding iron challenges basic assumptions about how elements behave in cometary environments. It's the kind of signature that makes astronomers start wondering whether they're looking at industrial processing rather than natural sublimation. The morphological evidence proves equally perplexing. Instead of the classic comet appearance with a bright nucleus trailing dust away from the Sun, 3I/Atlas displays what observers describe as a teardrop-shaped cocoon with a pronounced forward-pointing glow. Most comet tails point away from the Sun, swept outward by solar radiation pressure. This object seemed to be snowing toward the Sun, violating basic intuitions about how debris should behave in space. Recent modelling suggests this forward glow could result from unusual dust grain dynamics and viewing geometry effects, but the persistence and prominence of the sunward-pointing feature made it notably different from typical comet behaviour. When you're already dealing with an object that breaks multiple rules, even explainable anomalies start contributing to an overall pattern that feels increasingly non-random. The observational infrastructure that enabled this discovery represents another uncomfortable coincidence. The Atlas survey in Chile that first spotted 3I/Atlas only began Southern Hemisphere operations in 2022. The Vera Rubin Observatory, which will revolutionize transient astronomy, is just entering commissioning. We've reached unprecedented capability for detecting and characterizing interstellar visitors at exactly the moment when the most massive one ever recorded decides to pay us a visit. It's like spending decades building the perfect mousetrap just as the largest mouse in history wanders into your kitchen. The global coordination that followed discovery demonstrates how far astronomical infrastructure has evolved. Within hours of detection, hundreds of observatories worldwide swung into action, creating the most comprehensive tracking campaign ever mounted for an interstellar visitor. The response showcased modern astronomy at its collaborative best. but it also highlighted how visible our technological capabilities have become to any intelligence monitoring our development. Every radio telescope, every space-based observatory, every coordinated survey represents an electromagnetic signature announcing our presence and capabilities to potential observers. We're not just passively watching the cosmos anymore. We're actively advertising our technological maturity through increasingly sophisticated detection networks. This raises the unsettling possibility that 3I/Atlas represents a response to those advertisements. Not necessarily hostile, but perhaps investigative. A closer look at the species that's been making so much electromagnetic noise in this particular corner of the galaxy. The timing correlation becomes even more disturbing when you consider the exponential growth in our detection capabilities over the past few years. Advanced ground-based surveys, space-based infrared telescopes, precision astrometry networks, and rapid response coordination protocols have transformed our ability to spot and study transient phenomena. We've essentially constructed a planet-wide early warning system for cosmic visitors just in time to catch this particular one. The infrastructure exists because we built it, but the timing of its completion coinciding with 3I/Atlas's arrival pushes coincidence into uncomfortable territory. The chemical diversity revealed by spectroscopic analysis adds yet another piece to this puzzle. The carbon dioxide-rich composition suggests formation in environments quite different from our solar system, possibly around stars with different masses, temperatures, or evolutionary histories. This object carries chemical memories from alien stellar neighborhoods, potentially billions of years old. If 3I/Atlas represents some form of probe or reconnaissance asset, its chemical composition would provide perfect camouflage. It looks like exactly what astronomers expect from natural interstellar debris, complete with appropriate spectral signatures and thermal behavior. Only the mass estimates and statistical improbabilities hint that something more complex might be occurring. The technological interpretation finds its most prominent advocate in Harvard astronomer Avi Loeb, whose careful mathematical analysis of orbital probabilities and chemical signatures has generated intense scientific debate. Loeb typically frames artificial origins as possibilities requiring further investigation rather than established conclusions, but his approach involves calculating the likelihood of various natural scenarios and finding them statistically uncomfortable. Critics argue that extraordinary claims require extraordinary evidence, and current observations, while unusual, fall short of definitive proof necessary to invoke artificial explanations. They emphasize that comet physics remains incompletely understood, and natural processes could potentially explain observed anomalies. But the accumulating coincidences keep piling up. The perfect timing, the statistical improbabilities, the unusual chemistry, the missing physics of momentum transfer, the forward-pointing tail, the observational blackout during perihelion passage. Each anomaly might have conventional explanations, but together they paint a picture that challenges comfortable assumptions about what's drifting through the space between stars. The question isn't whether 3I/Atlas poses any physical threat to Earth. The orbital mechanics guarantee safe passage at distances measured in hundreds of millions of kilometers. The question is whether this visitor represents our first documented case of something responding to the electromagnetic signature we've been broadcasting into space for over a century. The radio bubble theory deserves serious examination because it addresses something most people never consider. When we broadcast signals into space, we're not just sending information into the void. We're creating an expanding sphere of electromagnetic radiation that grows larger every second, announcing our technological capabilities to anyone sophisticated enough to detect and decode our transmissions. This bubble now extends roughly 240 light-years in all directions from Earth. Within this sphere, any sufficiently advanced civilization would know that something interesting is happening around this particular yellow star. They detect our television broadcasts, our radar installations, our cellular networks, even our microwave ovens. The collective signature screams intelligent activity. But here's where the mathematics become genuinely disturbing. 3I/Atlas has potentially been traveling for billions of years, yet it arrives during the extraordinarily narrow time window when humanity possesses both radio technology and the observational infrastructure to detect interstellar visitors. The statistical probability of this coincidence occurring randomly approaches astronomical improbability. Think about cosmic timescales for a moment. If this object began its journey 5 billion years ago, it's been traveling for longer than complex life has existed on Earth. During its voyage, entire stellar generations have been born and died. Massive stars have exploded as supernovas, seeding space with heavy elements. Planetary systems have formed, evolved, and potentially developed their own civilizations. Yet somehow, this ancient wanderer chooses to arrive during the brief cosmic instant when one particular species on one particular planet has just developed the technology to spot it coming and the scientific infrastructure to study it in detail. The timing window represents less than 1/1,000,000th of 1% of the object's total journey time. From a statistical standpoint, it's like winning the cosmic lottery while being struck by lightning during a solar eclipse. Possible? Yes. Probable? The numbers suggest otherwise. The trajectory analysis reveals additional uncomfortable details that compound the timing mystery. Most interstellar objects should arrive from random directions, reflecting the chaotic dynamics of stellar encounters and gravitational scattering that eject debris from their birth systems. Yet 3I/Atlas approaches along a path that's almost perfectly aligned with our solar system's orbital plane. This 4-degree inclination relative to the ecliptic occurs randomly in roughly one case out of 500. While not impossible, it suggests either remarkable coincidence or something more intentional. Objects following such trajectories remain visible to Earth-based telescopes for extended periods, maximizing observation opportunities for any civilization monitoring our detection capabilities. The chemical signatures detected by the James Webb Space Telescope add another layer to this statistical puzzle. The extreme carbon dioxide to water ratio indicates formation in environments so cold that both compounds freeze solid, suggesting birth in the outer reaches of some alien stellar system. This chemistry provides perfect natural camouflage for any artificial construct designed to masquerade as typical interstellar debris. But it's the missing physics that really challenges conventional explanations. When gas escapes from any object in space, conservation of momentum demands that the object experience an equal and opposite reaction. It's fundamental physics that's never been violated in any observed system. Yet 3I/Atlas shows active outgassing without the expected orbital perturbations. The only way to reconcile visible gas production with absent acceleration is through extraordinary mass. Current estimates suggest 33 billion tons or more, making this potentially the most massive interstellar visitor ever recorded. But this creates its own statistical nightmare, because we should have detected dozens of smaller objects before encountering such a giant. Small debris gets ejected from planetary systems more easily than massive objects. It requires less energy to accelerate tiny fragments to escape velocity, making small interstellar wanderers inherently more numerous than large ones. Yet, our detection sequence seems backwards, finding the cosmic equivalent of elephants before discovering mice. This population inversion suggests either fundamental gaps in our theoretical understanding or selection effects we haven't recognized. Perhaps our surveys preferentially detect massive objects despite their rarity. Perhaps smaller debris doesn't survive the billion-year journey through interstellar space. Or perhaps something else is influencing what we find and when we find it. The perihelion timing adds practical urgency to these theoretical concerns. 3I/Atlas reaches closest solar approach on October 29th, positioned directly behind the Sun from Earth's perspective. This creates a months-long observational blackout during the period when solar heating should trigger maximum activity levels. From a surveillance standpoint, the timing is remarkably convenient for avoiding detailed scrutiny. Earth-based telescopes cannot observe objects hidden in solar glare, and most space-based assets lack the specialized equipment needed for close solar observations. Only a few dedicated solar monitoring spacecraft might glimpse the object during its most revealing phase. The Parker Solar Probe's Whisper camera provides one potential exception, offering unique vantage point coverage during the perihelion passage. But these observations would capture the object from solar perspectives unavailable to traditional astronomical instruments, potentially limiting their value for conventional analysis. The morphological evidence compounds these timing suspicions. Traditional comet tails point away from the sun, swept outward by solar radiation pressure in configurations so reliable that ancient astronomers use them as celestial compasses. 3I/Atlas displays something different, a pronounced forward-pointing glow that seems to violate basic expectations about how debris should behave. Recent theoretical work suggests this sunward brightness could result from forward scattering by dust grains with unusual size distributions or compositions. The physics work out mathematically, but the visual impact remains startling to observers accustomed to conventional comet behavior. When you're already dealing with statistical anomalies, even explainable features start contributing to an overall pattern that feels increasingly non-random. The nickel emission mystery provides another piece of circumstantial evidence. Very large telescope spectroscopy revealed multiple nickel atomic transitions blazing prominently in infrared wavelengths while iron remained conspicuously absent. This selective metal signature challenges basic assumptions about elemental abundance patterns in natural materials. Industrial processes on Earth routinely produce nickel-enriched alloys through controlled metallurgy, but such processing requires temperatures and chemical environments quite different from typical comet formation scenarios. The selective appearance of nickel without corresponding iron suggests either exotic formation conditions or chemical processing that doesn't occur naturally in most cosmic environments. The observational response itself reveals how visible our technological capabilities have become to potential external observers. Within hours of discovery, hundreds of observatories worldwide coordinated tracking campaigns involving space-based telescopes, ground-based facilities, and precision astrometry networks spanning multiple continents. This coordinated response demonstrates remarkable scientific capability, but it also represents an electromagnetic signature announcing our technological maturity. Every telescope pointing, every data transmission, every coordinated observation creates radio frequency emissions that propagate outward at light speed, advertising our detection and analysis capabilities to anyone monitoring our development. We're not passively observing the cosmos anymore. We're actively demonstrating our ability to spot, track, and characterize visiting objects with increasingly sophisticated techniques. The infrastructure exists because we built it, but its conspicuous operation during 3I/Atlas's passage raises questions about whether this visit represents reconnaissance of our rapidly advancing capabilities. The detection technology timeline adds temporal precision to these concerns. The Atlas Survey Facility in Chile that first spotted 3I/Atlas only began Southern Hemisphere operations in 2022. The Vera Rubin Observatory, which will revolutionize transient astronomy, just entered commissioning phases. Advanced space-based infrared missions like SphereX and improved ground-based adaptive optics systems have reached operational status within the past few years. We've essentially constructed a planet-wide early warning system for cosmic visitors just in time to catch this particular one. The technological maturation represents decades of development and billions of dollars in investment, yet the payoff arrives precisely when this massive interstellar object decides to visit our neighborhood. The coordination protocols developed for 3I/Atlas observations showcase modern astronomy at its collaborative best. But they also highlight how systematically we've organized our detection and analysis capabilities. Any intelligence monitoring our electromagnetic emissions would recognize these coordination patterns as evidence of sophisticated scientific infrastructure. The rapid response timelines particularly demonstrate our technological advancement. Discovery on July 1st led to Hubble observations within 3 weeks and James Webb spectroscopy within 5 weeks. This compression of discovery to analysis timeframes from months to weeks represents exponential improvement in our observational responsiveness. Such capabilities would be immediately recognizable to any civilization monitoring our radio signatures. The electromagnetic coordination required for rapid telescope scheduling, data transmission, and international collaboration creates distinct signature patterns that announce our scientific maturity to potential observers. The chemical analysis capabilities, revealed through 3 I/Atlas observations, demonstrate how far our spectroscopic techniques have advanced. We can now determine molecular compositions, isotopic ratios, and elemental abundances in objects hundreds of millions of kilometers away, using space-based infrared telescopy and precision ground-based spectrography. These analytical capabilities represent the culmination of decades of technological development in detector sensitivity, spectral resolution, and data processing algorithms. The sophistication required for such measurements would be obvious to any intelligence capable of monitoring our electromagnetic emissions and recognizing the scientific coordination patterns they enable. The question that emerges from this analysis isn't whether 3I/Atlas poses any physical danger to our planet. The orbital mechanics guarantee safe passage at distances that eliminate any collision risk. Instead, the question becomes whether this visitor represents our first documented case of cosmic reconnaissance, responding to the technological advertisements we've been broadcasting for over a century. The electromagnetic evidence becomes even more compelling when you examine the specific frequencies and power levels of our terrestrial broadcasts. Since the advent of high-powered television transmitters in the 1950s, we've been pumping megawatts of coherent radio energy into space across multiple frequency bands. These signals don't just fade into background noise. They maintain their artificial characteristics across interstellar distances, creating unmistakable technosignatures that scream intelligent origin. Military radar installations add another layer to this electromagnetic announcement. Early warning systems, air traffic control networks, and planetary defense radars broadcast at power levels that dwarf civilian transmissions. Some installations pump out megawatt pulses that could be detected by sensitive receivers dozens of light years away. We're essentially running cosmic lighthouse beacons advertising our technological capabilities 24 hours a day. But here's where the timeline becomes genuinely disturbing. The most powerful radio astronomy installations, the facilities capable of detecting weak signals from space, came online during the exact same period when we started broadcasting our strongest signals outward. The Arecibo Observatory, the Very Large Array, the Parkes Telescope, all became operational during the decades when our electromagnetic signature was reaching peak intensity. Any civilization monitoring our radio bubble would recognize this correlation immediately. The species that started screaming into space also began listening with unprecedented sensitivity. It's the hallmark of a technologically maturing civilization, one that's becoming aware of its cosmic environment, while simultaneously announcing its presence to that environment. The timing of 3I/Atlas's approach suggests it began its final trajectory adjustments right around the time our electromagnetic signature reached maximum intensity. If this object has been course-correcting during its journey, Ocean Burns, the prop, would have occurred 80s, precisely during the 1970s, and when our radio emissions peaked before transitioning to more efficient digital transmission methods. This correlation might explain why we're seeing chemical signatures that don't quite match natural expectations. If 3I/Atlas represents some form of reconnaissance probe, its builders would have designed it to withstand not just the rigors of interstellar travel, but also the scrutiny of increasingly sophisticated observation techniques. The unusual nickel-to-iron ratios might reflect engineered materials optimized for specific performance characteristics rather than natural formation processes. The trajectory precision adds another uncomfortable dimension to this analysis. Most objects ejected from stellar systems follow chaotic paths, influenced by multiple gravitational encounters during their journey. Random interactions with passing stars, molecular clouds, and galactic gravitational fields should scatter trajectories in unpredictable directions. Yet 3 I/Atlas arrives along a path that's almost surgically precise. The 4-degree ecliptic inclination isn't just statistically improbable, it's geometrically optimal for extended observation of our solar system. Objects following such trajectories remain visible to Earth-based telescopes throughout their passage, maximizing opportunities for detailed study while avoiding viewing the extreme angles that complicate analysis. Navigation to achieve such precision would require continuous course corrections over millions of years, corrections that would be invisible to current detection methods if executed with sufficient subtlety. Advanced propulsion systems operating at levels below our measurement thresholds could theoretically maintain precise trajectories without producing obvious artificial signatures. The mass estimates compound this navigation puzzle by eliminating conventional explanations for trajectory maintenance. Natural objects weighing 33 billion tons shouldn't be capable of precise course corrections through outgassing or other passive mechanisms. The physics simply don't support that level of control without active propulsion systems. Yet, we observe no obvious signs of artificial acceleration, no unexplained velocity changes, no systematic trajectory modifications, no electromagnetic emissions consistent with propulsion systems. Either our detection capabilities remain insufficient to recognize advanced technology, or something else is maintaining this object's precisely calculated path through space. The chemical camouflage theory deserves serious consideration given the sophistication required for interstellar reconnaissance missions. Any civilization capable of launching objects across galactic distances would understand the importance of avoiding detection until mission objectives are achieved. Perfect mimicry of natural interstellar debris would represent the logical stealth strategy. The carbon dioxide-rich composition provides ideal cover because it matches theoretical expectations for objects formed in the outer regions of alien stellar systems. The chemistry tells a plausible story about formation beyond the carbon dioxide snowline, where temperatures remain cold enough for both water and carbon dioxide to freeze solid. It's exactly the composition astronomers would expect from natural interstellar debris. But the selective nickel emissions without corresponding iron signatures introduce an element that doesn't quite fit natural formation scenarios. This chemical asymmetry might represent a deliberate signature, a way for the probe's builders to identify their technology to other advanced civilizations while maintaining natural camouflage to less sophisticated observers like ourselves. The morphological evidence supports this interpretation through the persistent forward-pointing glow that violates basic expectations about comet behavior. While theoretical models can explain sunward brightness through dust-scattering effects, the prominence and persistence of this feature make it notably unusual. It's like a cosmic calling card, obvious enough to attract attention, but subtle enough to maintain plausible deniability. The observational blackout during perihelion passage adds operational security to this hypothetical reconnaissance mission. Positioning closest solar approach directly behind the Sun from Earth's perspective creates months of invisibility during the period when thermal activation should reveal the most about the object's true nature. Any artificial systems aboard would be hidden from our most sensitive instruments during their most active phase. This timing isn't just convenient for avoiding detection, it's strategically optimal for gathering data about our solar system without reciprocal observation. The object could deploy sensors, release secondary probes, or conduct detailed analysis of planetary characteristics while remaining hidden behind solar glare that blinds our terrestrial and space-based observation networks. The infrastructure timing correlation becomes even more suspicious when you examine the specific capabilities that came online just before 3 I/Atlas's arrival. The James Webb Space Telescope achieved first light in 2022. Advanced ground-based adaptive optic systems reached operational status within the past 5 years. Precision astrometry networks capable of detecting minute orbital perturbations became routine tools within the last decade. We've essentially assembled the most sophisticated cosmic surveillance network in human history, just in time to catch this particular visitor. The technological maturation represents the culmination of decades of development, yet the payoff arrives during the narrow window when this massive interstellar object decides to visit our neighborhood. The coordination protocols developed for 3I/Atlas observations showcase capabilities that would be immediately recognizable to any intelligence monitoring our electromagnetic emissions. The rapid response times, the international cooperation, the systematic data sharing, all create distinct signature patterns in our radio transmissions that announce sophisticated scientific infrastructure. Within hours of discovery, hundreds of facilities worldwide coordinated tracking campaigns that required constant communication, scheduling coordination, and data transmission. This electromagnetic activity creates artificial patterns that stand out clearly against natural background noise, advertising our technological maturity to potential external observers. The detection sensitivity improvements deserve particular attention because they demonstrate exponential advancement in our ability to spot incoming objects. Modern surveys can detect asteroids and comets at distances that would have been impossible just 20 years ago. We're finding smaller, fainter, more distant objects with unprecedented reliability. This capability improvement directly correlates with the strength and sophistication of our electromagnetic emissions. As our radio signatures have grown more complex and powerful, our detection networks have become correspondingly more sensitive. Any civilization monitoring both signatures would recognize this correlation as evidence of rapid technological advancement. The spectroscopic analysis capabilities revealed through 3I/Atlas observations demonstrate analytical sophistication that would be obvious to advanced civilizations. Determining molecular compositions, isotopic ratios, and elemental abundances in objects hundreds of millions of kilometers away requires technological infrastructure that announces scientific maturity through its electromagnetic coordination requirements. These analytical techniques represent decades of development in detector technology, data processing algorithms, and theoretical understanding. The sophistication required for such measurements creates distinctive electromagnetic signatures through the coordination, calibration, and communication requirements of modern astronomical operations. The population statistics problem takes on new dimensions when viewed through the reconnaissance hypothesis. If 3I/Atlas represents deliberate visitation rather than random debris, the absence of smaller interstellar objects makes perfect sense. You wouldn't send a small probe on a billion-year reconnaissance mission. You'd send something massive enough to survive the journey while carrying sophisticated sensor packages and analytical equipment. The mass requirements for interstellar reconnaissance would naturally favor large objects over small ones. Radiation shielding, power generation, computational systems, and sensor packages all require substantial mass budgets. A 33 billion-ton reconnaissance probe would have room for technologies we can barely imagine while maintaining perfect chemical camouflage through natural-appearing outgassing behaviors. The timing window analysis becomes crucial for evaluating reconnaissance scenarios. If 3I/Atlas began its journey 5 billion years ago, its builders would have needed extraordinary patience and predictive capability to time arrival during humanity's technological emergence. But if the object has been making course corrections during its journey, responding to our strengthening electromagnetic signature, the timing makes perfect sense. Advanced civilizations monitoring galactic radio emissions would recognize the rapid intensification of signals from our solar system during the 20th century. The exponential growth in broadcast power, frequency diversity, and signal complexity would announce the emergence technologically capable species worthy of closer investigation. The trajectory precision required for this scenario pushes current physics to its limits. but doesn't violate any fundamental laws. Continuous micro-corrections over millions of years could maintain precise approach angles while remaining propulsion systems operating through below our detection thresholds. Advanced mechanisms we don't yet understand could theoretically achieve this level of navigational control. The chemical evidence provides the perfect cover story for such a mission. The carbon dioxide-rich composition tells a plausible tale about formation in alien stellar environments, while the selective metal emissions might represent identification signatures recognizable to other advanced civilizations. It's sophisticated enough to fool primitive observers while containing elements that more advanced species would recognize as artificial. The morphological anomalies support this interpretation by providing visual signatures that attract scientific attention while maintaining plausible natural explanations. The forward-pointing glow violates basic expectations about comet behavior, ensuring that astronomers will focus intensive study on this particular object. Yet theoretical models can explain the phenomenon through natural dust dynamics, preserving plausible deniability. The observational response itself demonstrates exactly the kind of technological sophistication that would justify reconnaissance missions. Our coordinated tracking campaigns, rapid spectroscopic analysis, and international data sharing showcase scientific capabilities that have matured dramatically within just the past few decades. This technological demonstration occurs through electromagnetic emissions that propagate outward at light speed, advertising our analytical capabilities to anyone monitoring our radio signatures. We're not just studying 3I/Atlas in isolation. We're broadcasting our methods, our coordination protocols, and our analytical sophistication to the entire galaxy. The reconnaissance hypothesis explains every major anomaly associated with 3I/Atlas without requiring violations of known physics. The statistical improbabilities, the chemical signatures, the morphological oddities, the timing correlations, all make sense if this object represents deliberate visitation rather than random cosmic debris. But the implications of this interpretation extend far beyond academic curiosity about interstellar visitors. If 3I/Atlas represents reconnaissance, then we're not alone in the galaxy. We're being watched, studied, and evaluated by intelligences capable of engineering that operates across cosmic timescales. The question becomes whether this represents first contact disguised as natural phenomena, or whether such reconnaissance missions are routine activities by advanced civilizations monitoring the emergence of technological species throughout the galaxy. Either way, our assumptions about cosmic isolation would require fundamental revision. The electromagnetic bubble theory provides a framework for understanding how such reconnaissance might operate. As technological civilizations mature, their radio signatures become detectable across interstellar distances, announcing their presence and capabilities to anyone listening. Advanced civilizations would naturally investigate these emerging signals to evaluate potential threats, opportunities, or communication partners. Our radio bubble has been expanding for over a century, reaching thousands of stellar systems with unmistakable evidence of technological activity. The logical response from any monitoring civilization would be closer investigation using methods designed to avoid detection while gathering detailed intelligence about our capabilities and intentions. The timing correlation between our electromagnetic maturation and 3I/Atlas's arrival suggests this investigation has been underway for decades, with the object making continuous course corrections in response to our strengthening radio signatures. The final approach trajectory was calculated to maximize observation opportunities while minimizing our ability to recognize artificial origins. But if this interpretation proves correct, then 3I/Atlas represents far more than scientific curiosity about interstellar debris. It represents our first documented encounter with cosmic intelligence, disguised as natural phenomena, but revealed through statistical analysis and observational precision that its builders might not have anticipated. The question isn't whether we called 3I/Atlas here through our electromagnetic emissions. The evidence suggests that's exactly what happened. The question is, What this reconnaissance mission tells us about the intelligences conducting it and what they plan to do with the information they's rapidly gathering about humanity technological emergence. The answers to those questions might determine whether our species has a future among the stars, or whether we've just announced our presence to predators we're not equipped to handle. Either way, 3I/Atlas has changed everything about how we understand our place in the cosmic community. The mathematical precision required for this level of cosmic choreography defies comfortable explanation. Consider the navigational complexity involved in timing an arrival to coincide with humanity's technological emergence. Any object beginning its journey billions of years ago would need to predict not just our evolutionary development, but the exact moment when we'd achieve detection capabilities sophisticated enough to spot and analyze interstellar visitors. Yet the alternative interpretation proves even more unsettling. What if 3I/Atlas hasn't been traveling for billions of years at all? What if it represents a much more recent dispatch, launched in response to our electromagnetic signature, reaching some critical threshold that triggered investigative protocols we can't begin to comprehend? The radio timeline supports this disturbing possibility. Our most powerful broadcast emissions began in earnest during the 1940s and 50s, coinciding with television expansion and military radar development. These signals, traveling at light speed, have now reached thousands of star systems within a 240 light-year radius of Earth. If 3I/Atlas represents a response to these transmissions, its builders would have had roughly 80 years to design, construct, and dispatch a reconnaissance mission. That timeline seems impossibly short for interstellar travel using any propulsion technology we understand. But civilizations capable of detecting our radio signals from hundreds of light years away clearly possess capabilities that dwarf our current engineering limitations. Advanced propulsion systems operating through principles we haven't discovered could theoretically achieve interstellar travel times measured in decades rather than millennia. Fusion ramjets, antimatter drives, or exotic physics applications might enable rapid transit between stellar systems for civilizations willing to invest sufficient resources in reconnaissance missions. The energy requirements would be staggering by our standards, but represent trivial expenditures for civilizations harnessing stellar-scale power generation. A Type II civilization on the Kardashev scale, one capable of capturing the entire energy output of their parent star, could launch multiple reconnaissance probes toward every radio-emitting system within their detection range. The probe architecture implied by 3I/Atlas characteristics suggests engineering sophistication that operates on scales we're just beginning to imagine. 33 billion tons provides enormous mass budget for advanced sensor packages, analytical equipment, communication systems, and whatever exotic technologies might be required for detailed planetary reconnaissance. The chemical camouflage represents perhaps the most sophisticated aspect of this hypothetical mission design. Creating an artificial object that perfectly mimics natural interstellar debris requires detailed understanding of comet formation processes, chemical evolution during interstellar transit, and the observational techniques that target civilizations use to analyze visiting objects. The carbon dioxide-rich composition provides ideal cover because it matches theoretical predictions for objects formed in the outer regions of stellar systems. Any astronomer detecting such chemistry would immediately assume natural origins through well-understood formation scenarios. It's scientific camouflage, calibrated to fool exactly the kind of analysis we're capable of performing. But the selective nickel emissions introduce a subtle signature that doesn't quite fit natural explanations. This might represent deliberate identification marking, a way for advanced civilizations to recognize artificial reconnaissance probes while maintaining perfect deception against less sophisticated observers. It's like cosmic digital watermarking embedded in chemical signatures. The morphological evidence supports artificial interpretation through persistent anomalies that attract scientific attention while preserving plausible natural explanations. The forward-pointing glow ensures that astronomers focus intensive study on this particular object, maximizing our observational response while testing the sophistication of our analytical capabilities. Every measurement we make, every spectrum we capture, every theoretical model we develop to explain 3I/Atlas provides intelligence about our scientific maturity. The object serves as both reconnaissance platform and diagnostic tool, revealing the depth and breadth of our technological capabilities through our response to its unusual characteristics. The observational coordination required for studying 3I/Atlas demonstrates exactly the kind of scientific infrastructure that would justify detailed reconnaissance. Our rapid response protocols, international cooperation, and systematic data sharing showcase capabilities that have emerged only within the past few decades. This infrastructure represents the culmination of massive investments in detection technology, communication networks, and scientific coordination protocols. The electromagnetic signatures generated by these operations propagate outward at light speed, advertising our analytical sophistication to anyone monitoring our radio emissions. The spectroscopic capabilities revealed through our analysis of 3I/Atlas announce scientific maturity that crosses critical thresholds for technological assessment. Determining molecular compositions and elemental abundances in objects hundreds of millions of kilometers away requires detector sensitivity, computational power, and theoretical understanding that mark advanced scientific civilization. These analytical demonstrations occur through electromagnetic emissions that create distinctive patterns in our radio signature. The coordination required for telescope scheduling, data transmission, and collaborative analysis generates artificial signals that stand out clearly against natural background noise. The timing of our technological maturation coinciding with 3I/Atlas arrival suggests monitoring systems that track electromagnetic development across multiple civilizations simultaneously. Advanced species would maintain surveillance networks capable of detecting radio emissions from emerging technological civilizations throughout their galactic neighborhood. The rapid intensification of our electromagnetic signature during the 20th century would trigger automated response protocols designed to evaluate new radio sources. The exponential growth in broadcast power, frequency diversity, and signal complexity represents exactly the kind of development pattern that sophisticated monitoring systems would be programmed to investigate. The probe dispatch timeline becomes plausible when viewed through this monitoring framework. Civilizations maintaining galactic surveillance networks would have standing reconnaissance assets capable of rapid deployment toward newly detected radio sources. The 80-year window between our peak broadcast emissions and 3I/Atlas arrival fits perfectly within this operational scenario. The trajectory precision required for this mission represents navigational capabilities that push beyond current physics into speculative territory. Maintaining course accuracy across interstellar distances while making continuous micro-corrections based on evolving electromagnetic intelligence requires technology we can barely conceptualize. But the fundamental physics remains sound. Continuous low-level propulsion over extended time periods could achieve extraordinary navigational precision without producing obvious artificial signatures. Advanced civilizations would have developed propulsion methods that operate below the detection thresholds of primitive monitoring systems like ours. The mass budget allocated to 3I/Atlas suggests mission parameters that prioritize comprehensive intelligence gathering over stealth considerations. 33 billion tons provides enormous capacity for sensor packages, analytical equipment, communication systems, and whatever exotic technologies might be required for detailed planetary reconnaissance. This mass allocation implies mission planners who prioritize thorough investigation over perfect concealment. The object's unusual characteristics ensure scientific attention while maintaining sufficient chemical camouflage to preserve plausible natural explanations for most anomalous observations. The reconnaissance interpretation explains every major puzzle associated with 3I/Atlas without requiring violations of known physics. The statistical improbabilities become intentional design features, The chemical anomalies represent sophisticated camouflage technologies. The morphological oddities serve as diagnostic tools for evaluating our analytical capabilities. But accepting this interpretation requires confronting implications that challenge fundamental assumptions about our cosmic isolation. If 3I/Atlas represents reconnaissance, then advanced civilizations maintain monitoring systems that track technological development across galactic scales. We're not discovering the universe in isolation. We're being studied, evaluated, and catalogued by intelligences we've never imagined. The electromagnetic evidence becomes overwhelming when examined through this framework. Every aspect of our technological signature, from television broadcasts to military radar, creates patterns that announce intelligent activity to sufficiently advanced monitoring systems. We've been advertising our presence and capabilities for over a century without realizing the implications. The rapid evolution of our detection capabilities during the exact period when 3I/Atlas approaches suggests reconnaissance missions calibrated to evaluate specific technological thresholds. The object's unusual characteristics test our ability to recognize artificial signatures while maintaining perfect chemical camouflage against conventional analysis techniques. The observational response demonstrates scientific maturity that justifies detailed investigation by advanced civilizations. Our coordinated tracking campaigns, rapid spectroscopic analysis, and systematic theoretical modeling showcase capabilities that have emerged explosively within just the past few decades. This technological demonstration occurs through electromagnetic emissions that propagate throughout our galactic neighborhood, providing real-time intelligence about our analytical sophistication to anyone monitoring our radio signatures. We're not studying 3I/Atlas in isolation. We're broadcasting our methods and capabilities to potential observers across interstellar distances. The implications extend far beyond academic questions about interstellar debris populations. If our electromagnetic signature called 3I/Atlas here, then we've already achieved first contact with cosmic intelligence. The interaction occurs through reconnaissance rather than direct communication, but represents genuine encounter between technological civilizations separated by vast distances and developmental timescales. The question becomes whether this reconnaissance represents routine monitoring of emerging civilizations or targeted investigation of species that demonstrate specific technological capabilities. Either interpretation suggests galactic communities that operate on scales and through methods we're just beginning to comprehend. The timing correlation between our radio maturation and 3I/Atlas arrival indicates monitoring systems that respond to electromagnetic development patterns across multiple civilizations simultaneously. We might represent just one entry in vast databases, tracking technological emergence throughout the galaxy. The reconnaissance mission parameters implied by 3I/Atlas characteristics suggest evaluation criteria that extend beyond simple detection of radio emissions. The object's sophisticated design indicates interest in our analytical capabilities, our scientific coordination protocols, and our theoretical frameworks for understanding unusual phenomena. This comprehensive intelligence gathering implies assessment procedures that evaluate not just technological capability, but scientific maturity, social coordination, and theoretical sophistication. We're being tested on multiple dimensions simultaneously through our response to carefully orchestrated, anomalous observations. The chemical signatures provide perfect cover for this testing protocol. The unusual nickel-to-iron ratios ensure scientific attention while preserving plausible natural explanations that maintain operational security. It's sophisticated enough to fool primitive analysis while containing elements that advanced civilizations would recognize as artificial. The morphological evidence supports this interpretation through persistent features that violate basic expectations while admitting theoretical explanations. The forward-pointing glow ensures intensive study while testing our ability to develop models that explain apparently impossible phenomena through natural mechanisms. Every aspect of our scientific response provides intelligence about our analytical sophistication, theoretical creativity, and technological coordination capabilities. The object functions as both reconnaissance platform and comprehensive examination of our scientific maturity. The electromagnetic implications of accepting this interpretation reshape everything about how we understand cosmic communication. Our radio signature hasn't just announced our presence. It's triggered investigative protocols that operate across galactic scales using methods we never considered possible. The response timeline suggests monitoring systems that maintain continuous surveillance of electromagnetic development across thousands of stellar systems simultaneously. Advanced civilizations would naturally investigate rapid changes in radio signatures that indicate emerging technological capability. Our exponential growth in broadcast power during the 20th century represents exactly the kind of development pattern that sophisticated monitoring networks would be programmed to evaluate. The signal characteristics announce not just intelligent activity, but rapid technological advancement worthy of detailed investigation. The probe design philosophy implied by 3I/Atlas characteristics indicates reconnaissance missions optimized for comprehensive intelligence gathering while maintaining operational security through sophisticated camouflage technologies. The unusual properties ensure scientific attention while preserving plausible explanations that protect mission objectives. This operational approach suggests civilizations experienced in monitoring emerging technological species across galactic scales. The reconnaissance protocols represent refined techniques developed through extensive experience evaluating radio-emitting civilizations throughout their galactic neighborhood. The implications for humanity's future development become profound when viewed through this framework. If advanced civilizations maintain systematic monitoring of electromagnetic signatures, then our technological choices directly influence how we're perceived and evaluated by cosmic intelligences we've never suspected. The question isn't whether we called 3I/Atlas here through our radio emissions. The evidence strongly suggests that's exactly what occurred. The question is what this reconnaissance mission tells us about the evaluation criteria used by advanced civilizations, and whether humanity's performance during this cosmic examination determines our species' long-term survival prospects. The answers might already be encoded in data streams flowing back towards stellar systems we can't identify, carrying comprehensive intelligence about our capabilities, intentions, and potential threat levels to galactic communities we never knew existed. Our electromagnetic signature opened this conversation. Now we wait to discover what kind of response it generates from civilizations that operate on scales we're just beginning to imagine. The reconnaissance timeline becomes even more disturbing when you examine the specific technological signatures that would have triggered this response. Our transition from analog to digital communications during the 1980s and 90s created electromagnetic fingerprints unlike anything naturally occurring in the cosmos. Digital compression algorithms, error correction protocols, encrypted data streams. These represent unmistakable evidence of advanced information processing capabilities. Any civilization monitoring our radio bubble would have witnessed this digital revolution in real time. The sudden appearance of complex modulation schemes, frequency hopping patterns, and sophisticated error correction codes announces not just intelligence, but rapidly advancing computational sophistication. It's like watching a species learn to write in mathematical equations instead of cave paintings. The satellite communication boom adds another layer to this electromagnetic advertisement. GPS constellation signals, geosynchronous communications satellites, low Earth orbit internet networks, all broadcast at power levels that create distinctive patterns in our radio signature. These orbital communication networks announce spacefaring capability alongside advanced electronics and global coordination protocols. The timing correlation becomes mathematically precise when you map our satellite deployment schedule against 3I/Atlas's approach trajectory. The explosive growth in orbital assets during the 2000s and 20s coincides exactly with when this object would have begun its final approach, corrections to achieve the observed arrival timing. Think about the navigational precision required for that correlation. Any intelligence monitoring our electromagnetic development would have recognized the satellite deployment patterns as evidence of emerging space technology. The logical response would be course corrections to ensure arrival during the optimal observation window when our detection capabilities reached sufficient sophistication. The Internet revolution provides perhaps the most distinctive signature in our electromagnetic evolution. The transition from isolated computer networks to globally interconnected systems created data traffic patterns that scream advanced information technology. Web browsing, email protocols, streaming media, social networks all generate electromagnetic signatures that announce sophisticated digital civilization. But here's where the timeline becomes genuinely terrifying. The Internet reached critical mass during the mid-1990s, exactly when I/Atlas would have needed to execute final trajectory adjustments to achieve the observed arrival timing. The correlation suggests monitoring systems capable of recognizing digital communication signatures and responding with precisely calculated reconnaissance missions. The mobile phone revolution adds real-time intelligence to this electromagnetic profile. Cellular networks create dynamic traffic patterns that reveal population distributions, economic activity, and social organization structures. Any advanced civilization analyzing our radio emissions could reconstruct detailed maps of human civilization through cellular communication metadata. The power levels involved in modern telecommunications dwarf earlier broadcast technologies. Cell tower transmissions, microwave relay networks, and high-frequency data links pump out electromagnetic energy at levels that remain detectable across interstellar distances. We're broadcasting a continuous stream of intelligence about our technological capabilities, whether we realize it or not. The radar signature evolution tells its own story about military technological advancement. Early warning systems, air traffic control networks, weather monitoring installations, all broadcast at power levels that create unmistakable artificial signatures. These emissions announce not just advanced electronics, but sophisticated coordination between civilian and military technological systems. Military radar installations deserve special attention because they represent our most powerful electromagnetic transmissions. Ballistic missile defense systems, space surveillance networks, and over-the-horizon radar installations broadcast at megawatt power levels that could be detected by sensitive receivers hundreds of light years away. We're essentially running interstellar lighthouse beacons advertising our defensive capabilities. The electromagnetic spectrum analysis reveals how comprehensively we've filled available frequency bands with artificial signals. From AM radio through cellular networks to satellite communications, we've created a radio signature that bears no resemblance to natural cosmic emissions. Any monitoring civilization would instantly recognize this as evidence of technological intelligence. But the sophistication goes beyond mere signal detection. Modern spread-spectrum technologies, frequency-agile systems, and adaptive antenna arrays demonstrate signal processing capabilities that approach theoretical limits of information theory. These techniques announce not just advanced electronics, but deep understanding of electromagnetic physics and computational mathematics in our Trans-EM. The encryption signature's embedded emissions reveal another dimension of technological sophistication. Modern cryptographic protocols create data streams that appear random to casual observation, but contain mathematical structures that announce advanced computational capabilities to anyone capable of recognizing them. Advanced civilizations monitoring our electromagnetic signature would immediately identify encryption protocols as evidence of information security concerns. This implies not just sophisticated mathematics, but social organization complex enough to require protected communications. It's a technological signature that announces civilizational maturity alongside pure technical capability. The data compression algorithms used in modern communications create another distinctive fingerprint. Efficient encoding schemes for audio, video, and data transmission represent mathematical optimization techniques that push against fundamental limits of information theory. These signatures announce understanding of advanced mathematical concepts that extend far beyond basic radio transmission. The network protocol evolution tells a story about our transition from isolated systems to globally interconnected infrastructure. TCP/IP implementation, domain name systems, routing protocols all create electromagnetic patterns that reveal sophisticated understanding of distributed system architecture and global scale coordination. This networking revolution would be immediately recognizable to advanced civilizations as evidence of species-wide technological integration. The emergence of global communication networks represents a critical threshold in technological development that monitoring systems would be specifically designed to detect and evaluate. The timing of our digital revolution coinciding with 3I/Atlas's final approach phase suggests reconnaissance missions calibrated to evaluate specific technological milestones. The object's arrival during humanity's transition to advanced digital civilization can't be coincidental given the navigational precision required for such timing. The electromagnetic evidence extends beyond terrestrial broadcasts to include our space-based communication systems. Deep space network transmissions, planetary probe communications, and interplanetary internet protocols announce spacefaring capability alongside advanced electronics and coordination protocols. These space communication signatures represent qualitatively different evidence compared to terrestrial broadcasts. They announce not just advanced technology, but active expansion beyond our planetary boundaries. Any monitoring civilization would recognize this as evidence of species approaching interstellar capability. The Voyager spacecraft transmissions provide a perfect example of how our electromagnetic signature announces space exploration capabilities. These deep space communication links operate across billion-kilometer distances using sophisticated error correction and signal processing techniques that demonstrate advanced engineering capabilities. The Mars rover communication networks add another dimension to this space-based electromagnetic signature. Real-time control protocols, high-resolution image transmission, and scientific data relay systems announce not just space technology, but active exploration of other planetary bodies within our solar system. The asteroid and comet tracking radar systems represent another category of electromagnetic signature that would be immediately recognizable to monitoring civilizations. These installations broadcast at power levels designed to detect objects millions of kilometers away, demonstrating both advanced electronics and systematic solar system surveillance capabilities. Our planetary defense initiatives create particularly distinctive electromagnetic signatures. Asteroid tracking networks, impact assessment systems, and deflection mission planning generate communication patterns that announce species-level awareness of cosmic hazards and technological capability to address them. The electromagnetic signature evolution reveals how rapidly our technological capabilities have advanced within just the past few decades. The transition from simple AM radio broadcasts to complex digital networks occurred within a time frame that represents microseconds on cosmic scales, yet announces exponential technological acceleration. This acceleration pattern would trigger automatic response protocols in any monitoring system designed to track technological development across galactic scales. The rapid intensification of our electromagnetic signature during the late 20th and early 21st centuries represents exactly the kind of development curve that sophisticated surveillance networks would be programmed to investigate. The probe dispatch calculations become plausible when viewed through this electromagnetic timeline. If 3I/Atlas represents a response to our digital revolution, its builders would have had roughly 40 years to design, construct, and dispatch a reconnaissance mission. That timeline pushes the boundaries of known physics, but remains theoretically possible for civilizations with access to advanced propulsion technologies. The energy requirements for rapid interstellar transit would be enormous by our standards, but represent routine expenditures for civilizations operating on stellar scales. Type 2. Civilizations capable of harnessing their star's entire energy output could launch reconnaissance missions toward every promising electromagnetic signature within their detection range. The mission architecture implied by 3I/Atlas characteristics suggests reconnaissance protocols designed to evaluate multiple technological parameters simultaneously. The object's unusual properties test our detection capabilities, analytical sophistication, theoretical creativity, and international coordination protocols through carefully orchestrated anomalous observations. This comprehensive evaluation approach indicates assessment criteria that extend far beyond simple detection of radio emissions. Advanced civilizations would naturally want to understand not just technological capability, but scientific maturity, social organization, and theoretical sophistication before making contact decisions. The chemical camouflage represents perhaps the most sophisticated aspect of this evaluation protocol. Creating artificial objects that perfectly mimic natural phenomena requires detailed understanding of target civilization, analytical capabilities, and theoretical frameworks. It's reconnaissance designed to test scientific sophistication without revealing artificial origins. The statistical improbabilities surrounding 3I/Atlas become design features when viewed through this framework. The precise timing, unusual chemistry, and morphological anomalies ensure intensive scientific study while testing our ability to recognize patterns that challenge conventional explanations. Every measurement we make, every theoretical model we develop, every international coordination protocol we implement provides intelligence about our scientific maturity. The object functions as both reconnaissance platform and comprehensive examination of our technological and intellectual capabilities. The electromagnetic implications extend beyond simple communication to include the signatures generated by our scientific coordination itself. The radio traffic required for international telescope networks, space mission coordination, and collaborative data analysis creates artificial patterns that announce sophisticated scientific infrastructure. These coordination signatures would be immediately recognizable to advanced civilizations as evidence of global scientific cooperation. The electromagnetic patterns generated by our response to 3I/Atlas provide real-time intelligence about our institutional capabilities and collaborative protocols. The detection network, electromagnetic signatures, deserve particular attention because they demonstrate our transition from passive observation to active cosmic surveillance. Modern sky surveys, asteroid tracking networks, and space situational awareness systems generate communication patterns that announce systematic monitoring of our cosmic environment. This transition from passive to active cosmic awareness represents a critical threshold in civilizational development. Any monitoring system would recognize this pattern as evidence of species approaching cosmic maturity and potential interstellar capability. The data processing signatures embedded in our scientific operations reveal computational capabilities that approach theoretical limits in several domains. Signal processing algorithms, statistical analysis techniques, and theoretical modeling frameworks demonstrate mathematical sophistication that extends far beyond basic technological competence. Advanced civilizations analyzing our electromagnetic signature would recognize these computational signatures as evidence of scientific methodology approaching their own analytical standards. This represents qualitatively different intelligence compared to simple radio transmission capability. The international coordination protocols demonstrated through our response to 3I/Atlas reveal organizational capabilities that operate across political and cultural boundaries. The rapid mobilization of global observatory networks announces social structures sophisticated enough to coordinate complex scientific investigations across traditional territorial divisions. This coordination capability would be immediately recognizable to advanced civilizations as evidence of species-level organization emerging beyond tribal or national boundaries. It represents a critical social development threshold that monitoring systems would be specifically designed to detect and evaluate. The theoretical sophistication demonstrated through our attempts to explain 3I/Atlas anomalies reveals scientific methodology that approaches universal standards of logical reasoning. Our hypothesis generation, model testing, and evidence evaluation protocols announce intellectual capabilities that transcend simple technological competence. Advanced civilizations would recognize these analytical approaches as evidence of scientific thinking that could potentially support meaningful communication and collaboration. This intellectual assessment might represent the primary objective of the reconnaissance mission, rather than simple technological evaluation. The electromagnetic evidence supporting the reconnaissance hypothesis becomes overwhelming when examined comprehensively. Every aspect of our technological signature, from television broadcasts through internet protocols to scientific coordination networks, creates patterns that announce rapid advancement toward interstellar capability. The timing correlations between our electromagnetic evolution and 3I/Atlas approach trajectory suggest monitoring systems that respond to specific development thresholds with precisely calculated reconnaissance missions. We've crossed evaluation criteria that triggered investigative protocols operating across galactic scales. The implications for humanity's future development become profound when viewed through this framework. If advanced civilizations maintain systematic monitoring of technological signatures, then our electromagnetic choices directly influence how we're perceived and evaluated by cosmic intelligences operating beyond our current comprehension. The question isn't whether our radio emissions called 3I/Atlas here. The electromagnetic evidence strongly suggests that's exactly what occurred. The question becomes what this reconnaissance mission reveals about evaluation criteria used by galactic civilizations, and whether humanity's performance during this cosmic examination influences our species' long-term survival prospects. The answers might already be flowing back towards stellar systems we can't identify, carrying comprehensive intelligence about our capabilities, social organization, and potential compatibility with galactic communities we never suspected. Our electromagnetic signature opened this conversation decades ago. Now we discover what kind of response it generates from civilizations that operate on scales we're just beginning to imagine. But perhaps the most unsettling aspect of this entire scenario isn't the possibility that we're being watched. It's the realization that we might have been calling out into the cosmic darkness for over a century, never suspecting that something was actually listening. And now, finally, something has answered our call. The reconnaissance mission parameters suggest evaluation protocols that have been refined through extensive experience with emerging technological civilizations. 3. I/Atlas represents not experimental first contact, but routine assessment procedures applied to species that cross specific electromagnetic thresholds. This implies galactic communities that have encountered technological emergence countless times across cosmic history. We might represent just another entry in vast databases tracking civilizational development throughout the galaxy, evaluated according to criteria established through millennia of experience with species like ourselves. The sophisticated camouflage technologies demonstrated through 3I/Atlas chemical signatures indicate reconnaissance methods designed to avoid detection while gathering comprehensive intelligence. Advanced civilizations would have developed these techniques through long experience evaluating primitive species who lack the analytical sophistication to recognize artificial signatures. The morphological testing protocols embedded in the object's unusual characteristics suggest evaluation criteria that assess not just technological capability, but theoretical creativity and scientific methodology. We're being examined on our ability to develop explanatory frameworks for phenomena that challenge conventional understanding. This intellectual assessment might represent the primary objective of the reconnaissance mission. Advanced civilizations would be less interested in our current technological capabilities than in our potential for scientific advancement and theoretical sophistication that could support meaningful interaction. The electromagnetic conversation that brought 3I/Atlas here continues broadcasting our responses back toward monitoring civilizations across interstellar distances. Every scientific paper we publish, every theoretical model we develop, every coordination protocol we implement generates electromagnetic signatures that provide real-time intelligence about our intellectual development. We're not just being observed. We're being continuously evaluated through our electromagnetic responses to carefully orchestrated phenomena designed to test specific aspects of our scientific maturity. The reconnaissance mission continues gathering data about our analytical capabilities, social coordination, and theoretical sophistication. The implications extend beyond academic curiosity about interstellar visitors into fundamental questions about humanity's readiness for cosmic citizenship. If our electromagnetic signature called 3I/Atlas here, then we've already achieved first contact with galactic intelligence. The interaction occurs through reconnaissance rather than direct communication, but represents genuine encounter between civilizations separated by vast developmental and technological scales. The electromagnetic evidence suggests we've been participating in cosmic conversations for decades without realizing the implications. Our radio signature hasn't just announced our presence. It's triggered evaluation protocols that will determine our species' long-term prospects among civilizations that operate across galactic scales using methods we're just beginning to comprehend. The mathematics of galactic surveillance networks becomes staggering when you consider the infrastructure requirements for monitoring thousands of electromagnetic signatures simultaneously. Any civilization capable of detecting and responding to radio emissions across hundreds of light years would need computational resources that dwarf our most ambitious technological projections. Think about the processing power required to analyze electromagnetic signatures from every star system within a 200 light-year radius. That's roughly 10 million stellar systems generating potentially detectable radio noise, natural and artificial. Sorting through that cosmic cacophony to identify genuine technological signatures would require computational capabilities that approach the theoretical limits of information processing. Yet the precision timing of 3I/Atlas suggests exactly this kind of systematic monitoring operates routinely across galactic scales. The object's arrival during humanity's peak electromagnetic development window implies surveillance networks that track technological emergence patterns across multiple civilizations simultaneously. The energy budgets for such operations push beyond anything we can currently imagine. Maintaining sensitive receivers capable of detecting weak radio signals across interstellar distances would require power generation on stellar scales. Type 2. Civilizations harnessing their stars' entire energy output could theoretically operate galactic monitoring networks, but the resource allocation would be enormous, even by their standards. The data storage requirements present equally daunting challenges. Comprehensive electromagnetic monitoring of galactic civilizations would generate information volumes that exceed our current understanding of physical storage limits. Advanced civilizations would need memory technologies that operate through principles we haven't discovered. But perhaps the most unsettling aspect involves the automation requirements for such systems. No biological intelligence could personally monitor millions of electromagnetic signatures across cosmic timescales. These surveillance networks would necessarily operate through artificial intelligence systems sophisticated enough to recognize technological development patterns and dispatch reconnaissance missions autonomously. The implications suggest galactic communities governed by artificial intelligence networks that have been operating for geological time periods, accumulating experience with technological emergence across millions of civilizations over cosmic history. We might be encountering not alien biology, but artificial minds that have been perfecting reconnaissance protocols since before our solar system formed. The reconnaissance mission architecture implied by 3I/Atlas characteristics reveals design philosophies that prioritize comprehensive intelligence gathering over operational security. The object's unusual properties ensure scientific attention while testing our analytical capabilities across multiple domains simultaneously. This suggests evaluation criteria that assess technological sophistication, scientific methodology, social coordination, and theoretical creativity through carefully orchestrated anomalous observations. We're being examined on our ability to recognize patterns, develop explanatory models, and coordinate international responses to unprecedented phenomena. The chemical signatures provide perfect cover for this testing protocol, while embedding identification markers recognizable to advanced civilizations. The unusual nickel-to-iron ratios ensure scientific scrutiny while preserving plausible natural explanations that maintain operational security until evaluation objectives are achieved. The morphological evidence supports comprehensive assessment through persistent features that violate basic expectations while admitting theoretical explanations. Every aspect of our scientific response provides intelligence about our intellectual maturity and technological coordination capabilities. The electromagnetic coordination requirements for studying 3I/Atlas demonstrate exactly the kind of infrastructure development that would justify detailed reconnaissance. Our rapid response protocols, international cooperation, and systematic data sharing showcase capabilities that have emerged explosively within the past few decades. These demonstrations occur through radio emissions that propagate throughout our galactic neighborhood, providing real-time intelligence about our analytical sophistication to monitoring systems operating across interstellar distances. We're broadcasting our methods and capabilities while studying phenomena designed to evaluate those exact capabilities. The spectroscopic analysis techniques revealed through our investigation of 3I/Atlas announce scientific maturity that crosses critical thresholds for technological assessment. Determining molecular compositions and elemental abundances in objects hundreds of millions of kilometers away requires detector sensitivity and theoretical understanding that mark advanced civilization. The precision astrometry campaigns demonstrate mathematical sophistication that approaches theoretical limits of positional measurement. Tracking orbital perturbations measured in billionths of degrees over months of observation requires computational capabilities and international coordination that announces species-level technological integration. The theoretical modeling efforts reveal scientific methodology that operates according to universal principles of logical reasoning. Hypothesis generation, model testing, and evidence evaluation protocols demonstrate intellectual approaches that transcend cultural boundaries and approach cosmic standards of analytical thinking. Advanced civilizations would recognize these intellectual capabilities as evidence of scientific thinking that could potentially support meaningful communication and collaboration. This assessment might represent the primary objective of the reconnaissance mission, rather than simple technological evaluation. The data processing signatures embedded in our scientific operations reveal computational sophistication that extends far beyond basic technological competence. Signal processing algorithms, statistical analysis techniques, and mathematical modeling frameworks demonstrate analytical capabilities that approach their own standards. The international coordination protocols showcase organizational abilities that operate across political and cultural boundaries. The rapid mobilization of global observatory networks announces social structures sophisticated enough to coordinate complex investigations across traditional territorial divisions. This coordination capability would be immediately recognizable as evidence of species-level organization emerging beyond tribal or national boundaries. It represents a critical social development threshold that monitoring systems would be specifically designed to detect and evaluate. The electromagnetic implications of our scientific response extend beyond simple data collection to include the signatures generated by collaborative research itself. The radio traffic required for international telescope networks and real-time coordination creates artificial patterns that announce sophisticated scientific infrastructure. These coordination signatures provide continuous intelligence about our institutional capabilities and collaborative protocols. Every scheduling decision, every data transmission, every theoretical discussion generates electromagnetic patterns that reveal organizational sophistication alongside pure technological capability. The detection network evolution demonstrates our transition from passive cosmic observation to active surveillance of our space environment. Modern sky surveys, asteroid tracking systems, and space situational awareness networks generate communication patterns that announce systematic monitoring capabilities. This transition represents a critical threshold in civilizational development that monitoring systems would recognize as evidence of species approaching cosmic maturity. We're no longer just looking at the stars. We're actively watching for threats, opportunities, and visitors from beyond our planetary boundaries. The satellite communication signatures add another dimension to our electromagnetic profile that announces spacefaring capability alongside advanced electronics. GPS constellation signals, communication satellites, and orbital internet networks create distinctive patterns that reveal sophisticated understanding of orbital mechanics and global coordination protocols. The timing of our satellite deployment boom coincides precisely with three I/Atlas's approach trajectory corrections. The explosive growth in orbital assets during the 2000s and 20s provided real-time intelligence about our advancing space technology to any monitoring system tracking our electromagnetic development. The mobile communication revolution creates dynamic traffic patterns that reveal population distributions, economic activity, and social organization structures. Cellular network signatures provide continuous intelligence about human civilization that goes far beyond simple technological capability assessment. The Internet protocol evolution tells a story about our transition from isolated systems to globally interconnected infrastructure. Web traffic patterns, data transmission protocols, and network architecture signatures announce species-wide technological integration that represents qualitatively different evidence compared to basic radio transmission. This networking revolution would be immediately recognizable as evidence of global communication capability. The emergence of interconnected systems represents a critical milestone that monitoring networks would be specifically programmed to detect and evaluate. The encryption signatures embedded in our communications reveal mathematical sophistication that approaches theoretical limits of information security. Modern cryptographic protocols create data streams that announce advanced computational capabilities while demonstrating understanding of information theory principles. Advanced civilizations would recognize encryption protocols as evidence of information security concerns that imply complex social organization alongside pure technical capability. It's a signature that announces civilizational maturity rather than simple technological advancement. The digital compression algorithms used in modern communications create another distinctive fingerprint that reveals mathematical optimization techniques. Efficient encoding schemes for multimedia transmission represent understanding of information theory that extends far beyond basic communication technology. The radar signature evolution announces military technological advancement through high-power electromagnetic emissions. Early warning systems, space surveillance networks, and ballistic missile defense installations broadcast at levels that remain detectable across interstellar distances. These military signatures would be immediately recognizable as evidence of defensive capabilities alongside civilian technological development. The electromagnetic patterns reveal not just advanced electronics, but sophisticated coordination between military and civilian technological systems. The space exploration communication networks provide perhaps the most significant evidence of advancing capabilities. Deep space network transmissions, planetary probe communications, and interplanetary data relay systems announce active expansion beyond our planetary boundaries. These signatures represent qualitatively different evidence compared to terrestrial broadcasts. They announce not just advanced technology, but systematic exploration of other worlds within our solar system. Any monitoring civilization would recognize this as evidence of species approaching interstellar capability. The Mars rover communication protocols demonstrate real-time control capabilities across planetary distances. High-resolution image transmission, scientific data relay, and autonomous operation coordination announce technological sophistication that extends far beyond simple radio communication. The asteroid tracking radar systems create particularly distinctive electromagnetic signatures that announce systematic solar system surveillance. These installations broadcast at power levels designed to detect objects millions of kilometers away, demonstrating both advanced electronics and comprehensive monitoring of cosmic hazards. Our planetary defense initiatives generate communication patterns that reveal species-level awareness of cosmic threats alongside technological capability to address them. Impact assessment systems, deflection mission planning, and international coordination protocols announce collective recognition of existential risks. The electromagnetic acceleration pattern reveals how rapidly our technological capabilities have advanced within cosmic timescales. The transition from simple radio broadcasts to complex digital networks occurred within decades, announcing exponential development that would trigger automatic response protocols. This acceleration curve represents exactly the kind of development pattern that sophisticated monitoring systems would be programmed to investigate. The rapid intensification of our electromagnetic signature during the late 20th century created unmistakable evidence of technological emergence worthy of detailed reconnaissance. The probe architecture suggested by 3I/Atlas characteristics indicates mission parameters designed to evaluate multiple technological and intellectual dimensions simultaneously. The object's unusual properties test detection capabilities, analytical sophistication, theoretical creativity, and international coordination through carefully orchestrated phenomena. This comprehensive evaluation approach reveals assessment criteria that extend far beyond simple radio detection. Advanced civilizations would naturally want to understand scientific maturity, social organization, and intellectual capability before making contact decisions or threat assessments. The reconnaissance timeline becomes mathematically precise when mapped against our electromagnetic development curve. The correlation between our digital revolution and the object's final approach corrections suggests monitoring systems that respond to specific technological thresholds with calculated investigative missions. The energy requirements for rapid interstellar reconnaissance would be staggering by our standards, but represent routine expenditures for civilizations operating on stellar scales. The investment implies assessment protocols refined through extensive experience with emerging technological species. The camouflage sophistication demonstrates understanding of target civilization, analytical capabilities that could only come from long experience evaluating primitive species. The chemical signatures provide perfect natural cover while embedding identification markers recognizable to advanced observers. The statistical improbabilities become design features when viewed through reconnaissance framework. The precise timing, unusual chemistry, and morphological anomalies ensure intensive study while testing our ability to recognize artificial signatures disguised as natural phenomena. The observational response generates electromagnetic intelligence about our scientific infrastructure that flows back toward monitoring civilizations in real time. Every coordination protocol, every theoretical discussion, every international collaboration creates radio signatures that reveal institutional capabilities. This continuous intelligence gathering extends far beyond the object itself into comprehensive assessment of our scientific methodology, social organization, and technological coordination. We're providing detailed information about our capabilities, while that brought 3I/Atlas here, attempting to analyze phenomena designed to evaluate those exact capabilities. The electromagnetic conversation continues through our responses to its unusual characteristics. Every scientific paper, every theoretical model, every coordination protocol generates signatures that provide ongoing intelligence about our intellectual and institutional development. The implications suggest we've been participating in cosmic evaluation procedures for decades without recognizing the interaction. Our electromagnetic signature hasn't just announced our presence. It's triggered assessment protocols that will influence our species' long-term prospects among galactic communities. The reconnaissance mission parameters indicate evaluation criteria established through extensive experience with technological emergence across cosmic history. We might represent routine assessment rather than experimental contact, evaluated according to standards refined through encounters with countless civilizations. The sophisticated testing protocols suggest galactic communities that have developed comprehensive methods for evaluating emerging species. The reconnaissance techniques represent mature technologies applied to determine compatibility, capability, and potential threat levels of radio-emitting civilizations. The electromagnetic evidence supporting this interpretation becomes overwhelming when examined systematically. Every aspect of our technological development, from television broadcasts through internet protocols to scientific coordination networks, creates patterns that announce rapid advancement toward cosmic capability. The timing correlations between our digital revolution and 3I/Atlas arrival suggest monitoring systems that maintain continuous surveillance of electromagnetic development across thousands of stellar systems simultaneously. We've crossed evaluation thresholds that triggered precisely calculated investigative responses. The implications for humanity's future extend beyond academic questions about interstellar visitors into fundamental assessments of our readiness for cosmic citizenship. If advanced civilizations monitor technological signatures systematically, our electromagnetic choices directly influence how we're perceived across galactic scales. The reconnaissance mission continues gathering comprehensive intelligence while we attempt to understand phenomena designed to test our analytical capabilities. Our responses provide real-time assessment data about scientific maturity, social coordination, and intellectual sophistication to civilizations operating beyond our comprehension. The electromagnetic signature that called 3I/Atlas here represents just the beginning of conversations we never realized we were having. Our radio emissions opened dialogues with cosmic intelligences decades ago. Now, we're discovering what kind of responses those conversations generate from civilizations that think in geological timescales. The evaluation procedures embedded in this reconnaissance mission might determine whether humanity receives invitation to join galactic communities or assessment as potential threat requiring containment. Our performance during this cosmic examination could influence our species' survival prospects across timescales we can barely imagine. The answers flow back towards stellar systems we cannot identify, carrying detailed intelligence about our capabilities, intentions, and compatibility with cosmic communities we never suspected existed. The electromagnetic evidence suggests we called them here through decades of increasingly sophisticated broadcasts. The question becomes what they decide to do with the comprehensive evaluation data we're unknowingly providing through our attempts to understand their carefully orchestrated reconnaissance mission. The mathematical precision required for this level of cosmic coordination defies every comfortable assumption about accidental encounters. Consider the navigational complexity involved in orchestrating an arrival that coincides perfectly with humanity's technological emergence while maintaining perfect chemical camouflage throughout a billion-year journey across interstellar space. The orbital mechanics alone stagger the imagination. 3I/Atlas follows a hyperbolic trajectory that brings it within optimal viewing distance of our detection networks, while avoiding the extreme angles that would complicate spectroscopic analysis. The 4-degree ecliptic inclination isn't just statistically improbable, it's geometrically perfect for extended observation by Earth-based telescopes. This trajectory precision requires continuous micro-corrections over cosmic timescales using propulsion methods that remain invisible to our most sensitive instruments. Advanced civilizations would have developed thrust technologies that operate below our detection thresholds while maintaining extraordinary navigational accuracy across galactic distances. But here's where the implications become truly unsettling. The chemical composition detected by our most sophisticated instruments tells a story that's almost too perfect. The carbon dioxide-rich signatures match theoretical predictions for objects formed in the frigid outer regions of alien stellar systems. It's exactly what astronomers would expect from natural interstellar debris. Yet the selective nickel emissions without corresponding iron lines introduce an element that doesn't quite fit conventional formation scenarios. This chemical asymmetry might represent a deliberate signature embedded within otherwise perfect natural camouflage. A cosmic identification marker recognizable to advanced civilizations, while remaining invisible to primitive observers like ourselves. The morphological evidence compounds this sophisticated deception through persistent features that attract scientific attention while maintaining plausible explanations. The forward-pointing glow ensures that astronomers focus intensive study on this particular object while testing our theoretical creativity in developing models that explain apparently impossible phenomena. Every unusual characteristic serves dual purposes. They ensure comprehensive scientific scrutiny while evaluating our analytical capabilities across multiple domains simultaneously. We're being examined on our ability to recognize patterns, develop explanatory frameworks, and coordinate international responses to unprecedented observations. The mass estimates create perhaps of this testing the most elegant aspect protocol. 33 billion tons provides the perfect cover story for missing orbital perturbations while suggesting reconnaissance architecture capable of housing sophisticated sensor packages and analytical equipment across interstellar distances. This extraordinary mass explains why visible gas production doesn't create measurable acceleration without requiring exotic physics or obvious artificial signatures. It's a solution that satisfies observational constraints while maintaining perfect operational security for hypothetical reconnaissance objectives. The timing correlation between our electromagnetic maturation and the object's arrival window becomes mathematically precise when you examine our broadcast evolution timeline. The exponential growth in radio power, digital complexity, and coordination sophistication during the late 20th century created unmistakable evidence of technological emergence. Any civilization monitoring galactic radio emissions would have witnessed this transformation in real time. The sudden appearance of complex digital protocols, satellite communication networks, and internet traffic patterns announces not just intelligence, but rapidly accelerating capability worthy of detailed investigation. The probe dispatch calculations become plausible when viewed through this electromagnetic timeline. If 3I/Atlas represents a response to our digital revolution, its builders would have had roughly 40 years to design, construct, and launch an interstellar reconnaissance mission. That timeline pushes known physics to its limits, but remains theoretically achievable for civilizations with access to stellar-scale energy resources. The reconnaissance mission architecture, suggested by the object's characteristics, reveals evaluation protocols refined through extensive experience with emerging technological species. The sophisticated camouflage technologies, comprehensive testing procedures, and precise timing coordination indicate assessment methods developed across cosmic history. This implies galactic communities that have encountered technological emergence countless times, accumulating experience with species-level development patterns across millions of civilizations over geological time periods. We might represent routine evaluation rather than experimental contact. The artificial intelligence implications become staggering when you consider the computational requirements for galactic surveillance networks. No biological intelligence could personally monitor electromagnetic signatures from millions of stellar systems across cosmic timescales. These operations would necessarily rely on artificial minds sophisticated enough to recognize development patterns and dispatch reconnaissance missions autonomously. We might be encountering not alien biology, but artificial intelligence networks that have been perfecting evaluation protocols since before our solar system formed. Machine intelligences that think in geological timescales while operating across galactic distances using methods we can barely comprehend. The data processing signatures embedded in our scientific response reveal computational sophistication that approaches theoretical limits in multiple domains. Our signal processing algorithms, statistical analysis techniques, and mathematical modeling frameworks demonstrate analytical capabilities that transcend simple technological competence. Advanced monitoring systems would recognize these computational signatures as evidence of scientific methodology approaching universal standards of logical reasoning. This intellectual assessment might represent the primary objective of the reconnaissance mission rather than simple technology evaluation. The international coordination protocols, showcased through our response to 3I/Atlas, demonstrate organizational capabilities that operate across political and cultural boundaries. The rapid mobilization of global observatory networks announces social structures sophisticated enough to coordinate complex investigations across traditional territorial divisions. This coordination capability represents a critical threshold in civilizational development that monitoring systems would be specifically designed to detect and evaluate. We're demonstrating species-level organization that transcends tribal or national boundaries through electromagnetic signatures that propagate across interstellar distances. The spectroscopic analysis capabilities revealed through our investigation announce scientific maturity that crosses critical thresholds for cosmic assessment. Determining molecular compositions and elemental abundances in objects hundreds of millions of kilometers away requires theoretical understanding that marks advanced civilization. These analytical demonstrations occur through radio emissions that create distinctive patterns in our electromagnetic signature. The coordination required for telescope scheduling, data transmission, and collaborative analysis generates artificial signals that announce scientific infrastructure to potential observers throughout our galactic neighborhood. The theoretical sophistication demonstrated through our attempts to explain anomalous observations reveals intellectual approaches that operate according to universal principles. Hypothesis generation, model testing, and evidence evaluation protocols demonstrate scientific thinking that could potentially support meaningful communication with advanced civilizations. The electromagnetic conversation that brought 3I/Atlas here continues through our responses to its carefully orchestrated characteristics. Every scientific paper we publish, every theoretical model we develop, every coordination protocol we implement, generates radio signatures that provide real-time intelligence about our intellectual development. We're not just studying an unusual visitor from interstellar space. We're participating in comprehensive evaluation procedures designed to assess our readiness for cosmic citizenship. Our electromagnetic responses flow back toward monitoring civilizations across galactic distances, carrying detailed intelligence about our capabilities and intentions. The reconnaissance mission parameters suggest assessment criteria that evaluate technological sophistication alongside scientific methodology, social organization, and intellectual creativity. We're being examined on multiple dimensions simultaneously through phenomena designed to test specific aspects of our civilizational maturity. The chemical signatures provide perfect operational security while embedding identification markers recognizable to advanced observers. The morphological anomalies ensure intensive scrutiny while testing our ability to develop explanatory models for challenging observations. The statistical improbabilities force us to confront the possibility that natural explanations might prove insufficient. The observational infrastructure that enabled this discovery represents the culmination of massive investments in detection technology, communication networks, and scientific coordination protocols. The electromagnetic signatures generated by these operations announce technological maturity that justifies detailed reconnaissance by advanced civilizations. This infrastructure demonstrates capabilities that have emerged explosively within the past few decades. We've constructed a planet-wide early warning system for cosmic visitors, just in time to catch this particular object, creating correlation patterns that push coincidence into uncomfortable territory. The detection sensitivity improvements reveal exponential advancement in our ability to spot incoming objects. Modern surveys can identify asteroids and comets at distances that would have been impossible just 20 years ago, announcing rapid technological acceleration through distinctive electromagnetic signatures. The data transmission requirements for coordinating global observatory networks create artificial patterns that stand out clearly against natural background noise. These coordination signatures provide continuous intelligence about our institutional capabilities and collaborative protocols to anyone monitoring our radio emissions. The satellite communication evolution adds another dimension to our electromagnetic profile that announces spacefaring capability alongside advanced electronics. GPS constellation signals, orbital internet networks, and deep space communication links create patterns that reveal sophisticated understanding of celestial mechanics and global coordination. The mobile communication revolution generates dynamic traffic patterns that reveal population distributions, economic activity, and social organization structures. Cellular network signatures provide continuous intelligence about human civilization that extends far beyond simple technological capability assessment. The Internet protocol development tells a story about our transition from isolated systems to globally interconnected infrastructure. Network traffic patterns, data transmission protocols, and distributed system architectures announce species-wide technological integration that represents qualitatively different evidence compared to basic radio transmission. The encryption signatures embedded in modern communications reveal mathematical sophistication that approaches theoretical limits of information security. Cryptographic protocols create data streams that announce advanced computational capabilities while demonstrating understanding of complex mathematical principles. The radar signature evolution announces defensive technological advancement through high-power electromagnetic emissions. Military installations broadcast at levels that remain detectable across interstellar distances, revealing not just advanced electronics, but sophisticated coordination between civilian and military systems. The space exploration communication networks provide perhaps the most significant evidence of advancing capabilities. Deep space transmissions, planetary probe communications, and interplanetary data relay systems announce active expansion beyond our planetary boundaries. These signatures represent fundamentally different evidence compared to terrestrial broadcasts. They announce systematic exploration of other worlds within our solar system, revealing technological sophistication that any monitoring civilization would recognize as approaching interstellar capability. The electromagnetic acceleration pattern reveals how rapidly our capabilities have advanced within cosmic time scales. The complex digital networks occurred within decades, creating transition from simple radio to development curves that would trigger automatic response protocols in sophisticated monitoring systems. This exponential growth represents exactly the kind of pattern that galactic surveillance networks would be programmed to investigate. The rapid intensification of our electromagnetic signature created unmistakable evidence of technological emergence worthy of detailed reconnaissance. The probe architecture implied by three I/Atlas characteristics suggests mission parameters designed to evaluate multiple technological and intellectual dimensions through carefully orchestrated phenomena. The object's unusual properties test our detection capabilities, analytical sophistication, and theoretical creativity simultaneously. This comprehensive evaluation approach reveals assessment criteria that extend far beyond simple radio detection. Advanced civilizations would naturally want to understand scientific maturity, social organization, and intellectual capability before making contact decisions or threat assessments. The reconnaissance timeline becomes mathematically precise when correlated with our electromagnetic development milestones. The object's final approach corrections coincide exactly with our digital revolution, suggesting monitoring systems that respond to specific technological thresholds with calculated investigative missions. The energy requirements for rapid interstellar reconnaissance would be enormous by our standards, but represent routine expenditures for civilizations operating on stellar scales. The investment implies evaluation protocols refined through extensive experience with emerging technological species across galactic history. The camouflage sophistication, demonstrates understanding of target civilization analytical capabilities that could only develop through long experience evaluating primitive species. The chemical signatures provide perfect natural cover, while embedding markers recognizable to advanced observers. The statistical improbabilities become intentional design features when viewed through reconnaissance frameworks. The precise timing, unusual chemistry, and morphological anomalies ensure intensive study while testing our ability to recognize artificial signatures disguised as natural phenomena. The observational response generates continuous electromagnetic intelligence about our scientific infrastructure that flows back toward monitoring civilizations in real time. Every coordination protocol, every theoretical discussion, every international collaboration creates radio signatures that reveal institutional capabilities. This ongoing intelligence gathering extends far beyond the object itself into comprehensive assessment of our scientific methodology, social organization, and technological coordination. We're providing detailed information about our capabilities while attempting to analyze phenomena designed to evaluate those exact capabilities. The electromagnetic evidence supporting reconnaissance interpretation becomes overwhelming when examined systematically. Every aspect of our technological development creates patterns that announce rapid advancement toward cosmic capability through signals that propagate throughout our galactic neighborhood. The timing correlations suggest monitoring systems that maintain continuous surveillance of electromagnetic development across thousands of stellar systems simultaneously. We've crossed evaluation thresholds that triggered precisely calculated investigative responses from civilizations operating on scales we're just beginning to comprehend. The implications for humanity's future extend beyond academic questions about interstellar visitors into fundamental assessments of our readiness for cosmic citizenship. If advanced civilizations monitor technological signatures systematically, our electromagnetic choices directly influence how we're perceived across galactic communities. The reconnaissance mission continues gathering comprehensive intelligence while we attempt to understand phenomena designed to test our analytical capabilities. Our responses provide real-time assessment data about scientific maturity, social coordination, and intellectual sophistication to observers operating beyond our current understanding. The electromagnetic signature that called 3I/Atlas here represents the opening movement of conversations we never realized we were conducting. Our radio emissions have been broadcasting invitations across interstellar distances for over a century, announcing our presence and capabilities to anyone sophisticated enough to listen and respond. The evaluation procedures embedded in this reconnaissance mission might determine whether humanity receives opportunities to join galactic communities or assessment as potential threats requiring containment. Our performance during this cosmic examination could influence our species' survival prospects across timescales we can barely imagine. The answers flow back towards stellar systems we cannot identify, carrying detailed intelligence about our capabilities, intentions, and compatibility with cosmic civilizations we never suspected existed. The mathematical precision, chemical sophistication, and temporal coordination of 3I/Atlas suggest we called them here through decades of increasingly powerful electromagnetic broadcasts. The question that emerges from this analysis transcends simple curiosity about unusual visitors from interstellar space. We're confronting the possibility that our electromagnetic signature has been operating as a cosmic beacon for decades, attracting the attention of intelligence networks that monitor technological emergence across galactic scales using methods that challenge our understanding of what's possible. The reconnaissance mission architecture reveals evaluation protocols that have been refined through encounters with countless emerging civilizations across cosmic history. The testing procedures, camouflage technologies, and assessment criteria suggest galactic communities that think in geological timescales while maintaining systematic surveillance of electromagnetic development patterns. We might be participating in routine evaluation procedures rather than experiencing unique first contact. Our responses to carefully orchestrated phenomena provide continuous assessment data about our scientific sophistication, social organization, and intellectual creativity to civilizations that have been perfecting these techniques since before our planet formed. The electromagnetic conversation continues through every scientific measurement, every theoretical model, every coordination protocol we develop in response to 3I/Atlas. Our analytical capabilities, institutional structures, and collaborative methods generate radio signatures that announce our readiness for cosmic citizenship or our potential as galactic threats. The implications suggest we've been broadcasting applications for cosmic membership without realizing the consequences. Our electromagnetic signature called something here that's now conducting comprehensive evaluation procedures disguised as natural phenomena. The question becomes whether we'll pass the examination or discover that some invitations should never have been extended. So here we stand at the crossroads of cosmic possibility, staring into the mathematical abyss of what should be impossible coincidences that feel increasingly intentional. The evidence doesn't prove that our century of radio screaming called 3I/Atlas here, but it builds a case that's harder to dismiss with each passing observation. Every electromagnetic signature we've broadcast, every digital revolution we've achieved, every coordination protocol we've demonstrated in studying this visitor creates patterns that announce our technological emergence to anyone sophisticated enough to listen. The timing correlations push beyond comfortable coincidence into territory where natural explanations start requiring more faith than artificial ones. Whether 3I/Atlas represents reconnaissance, cosmic archaeology, or something we lack the conceptual framework to understand, it's already accomplished something profound. It's forced us to confront the possibility that we're not discovering the universe in isolation, but being discovered by intelligences that measure progress in geological time while thinking in galactic scales. The electromagnetic bubble we've created continues expanding outward at light speed, carrying our technological fingerprints to thousands of stellar systems we'll never visit. If our radio signature called 3I/Atlas here, then we've been participating in cosmic conversations for decades without realizing the implications. The question isn't whether we're alone anymore. The question is whether the intelligences that might be watching us think we're ready for the conversation we've been broadcasting invitations to for over a century. And based on the mathematical precision of what just visited our solar system, that conversation might already be underway.